This is the Unit 7 Lesson 1 video about simplifying rational expressions. The video will walk through the first warm-up of the unit, which is a review of the computation of fractions, and the Lesson 1 notes, which is fairly much a review of the rational expressions simplification that you learned in Algebra 2. So it should feel like review to you, but I have found that most pre-calc students really need a thorough review of the simplifying rational expressions. Just a note before we get started, and I'll remind you of this later, make sure that you are pretty good at factoring before you try to do this lesson. I am not going to, for the most part, unless there's one that's particularly tricky, I'm not going to walk you through how to factor any of the expressions. I will expect you to be stopping and starting, pausing and unpausing the video when we get to each problem as I walk through it. So I'll say, here's a problem, factor the numerator and denominator, pause, then you'll factor, and then you'll come back and I'll have factored it. But I'm not going to say, here's how to factor this expression. So, ready? Oh, and also, I know that some of you don't have the handouts in front of you. I wasn't able to get those out to you, and my apologies for that, but really all of this content is stuff that you can do with notebook paper. Just get the problems copied down correctly so that you're not trying to work out something that's not factorable because you copied it wrong. But you should be able to do this whole unit without the handouts. So here we go. So this is warm-up 1, and as you can see, there's no x's in any of the problems. It's all fractions. So what I would like you to do first is to pause the video on this page, do as much of these problems as you can, and then start the video up again. What I will do is probably just give you the answers worked out for the first 6 or 9 problems, and then I will walk you through the last 3 or 4 problems so that you can see how I've worked them out, especially the complex fractions you may not have a good handle on. So go ahead and pause the video. So, actual elevator music, huh? No? No. All right. I'll try to find something else to entertain you while you're pausing the video in the future. Anyway, here are the answers already worked out for the first 6 problems. Remember that when you're adding and subtracting fractions, you need to have common denominators, and none of these were given to you straight up with already common denominators. So you had to choose a common denominator for each one of them. In problems like number 1, one of the numbers goes into the other number. You can just use the bigger number as your common denominator and then just change the other fraction. In problems like number 2, neither number divides evenly into the other number, and so you're going to have to use some multiple that matches both of those numbers in order to find the common denominator. And in this case, you don't need to be, you can use 54, which is 9 times 6, multiplying the 2 denominators, but there's a smaller number that would be easier to work with. So if you just noodle with the numbers a little bit, you can find that number. But in number 3, when there's no other smaller common denominator, you would need to multiply the two denominators by each other to find a common denominator. Notice in numbers 4 and 5 that I've given you a whole number, and you just consider for number 4, for example, that that's like 1/5 minus 4 over 1. And so your denominator that you're working with is 1, and you need that denominator to be a 5 in order to have the common denominators, and so that would be 20 over 5. Also notice that you can get negative answers, that negative numerators are not off bounds. What I wanted to do then was pick up with number 7 real quick and talk you through these last 6 problems. So 4/10 times 15 over 7. When you were taught to multiply fractions, your teacher probably taught you to multiply the numerators and denominators, and then if you did that, you would get 60 here over 70 here, and then you would have to reduce the fraction to get 6/7. And what I want to do is show you that the way I was taught to multiply fractions, I was taught to actually go ahead and simplify the fractions that you have, that you have 2 numerators and 2 denominators, and that you can cancel any common factor from any numerator to any denominator. So for example here, 4 and 10 are both divisible by 2, and then 5 also goes into 15 3 times. And then if you multiply 2 times 3 in the numerator, you get 6, and if you multiply 1, this is when you canceled out the 5, that was a 1, I didn't write it. When you multiply the 1 times the 7, you should get 7. And so either way, you end up with 6/7, but I like to cancel before I multiply the bigger numbers. So then in number 8, if I do it that way, I can take the 2 and the 14, divide them both by 2, and now I have smaller numbers to work with, and my answer is going to be 11 over 28. And in number 9, with the division, just remember that you need to rewrite the division problem as multiplying and then flip or take the reciprocal of the second fraction, or whatever fraction is after the divide sign. So that whole part of the problem is going to become multiplying by the reciprocal. Please, I have seen students say, oh, I can just do the flip and the multiply in my head, and then they're drawing arrows all over the place. And I have found that those are the students that are more likely to make mistakes. And so I would really prefer that you actually write out the multiplication problem with the flipped second fraction and then do the multiplication. So 7 divides into 14 twice, and I have here 5 in the numerator over 18 in the denominator. Now, for number 10, we have a fraction being divided by a fraction, right? A fraction represents a division to begin with. And so really what we're saying here is that we are doing 5/7 divided by 45 over 14. So I would actually just go ahead and rewrite that as 5/7 divided by 45 over 14. And remember that a division problem is when you change the division to multiplication and take the reciprocal of the fraction that's immediately after the divide sign. And then I like to cancel. So here 7 goes into 14 twice, 5 goes into 45 9 times, And my answer for that whole thing is 2/9. In this problem, I would say that if you really understand these complex fractions, that if you don't want to write that, you may not need to show this one. Don't write this down, but you may not need to show this for your own use. So you could go straight from the complex fraction to the multiplication problem. So in number 11, what's different is that you have your numerator here, the big numerator, is an addition problem in and of itself. So I would start this problem by going ahead and doing that addition in the numerator, so that you get 6/5 over 15 halves, or 15/2. And then I would write my division and or multiplication problems. So 6/5 times 2/15. I skipped writing it as a division problem. If you want to write that again, you can. But then you change it to multiplication and flip the second fraction over. And I end up seeing that 3 goes into 6 twice and into 15 5 times. Nothing else. There's no other common factors that would cancel. And 2 times 2 is 4, and 5 times 5 is 25. And then in this one, your numerator is, again, an addition problem. And this time there are unlike denominators. So I'm going to use 6 as a denominator, and I'm going to change 3/2 to 9/6. And I'm going to change 2/3 to 4/6. So I'm adding 9/6 plus 4/6. And that way I get 13/6 all over 5/12. I'll rewrite that as a multiplication problem. 13/6 times 12/5. And again, I see that 6 goes into 12 twice. 13 times 2 is 26, and 1 times 5 is 5. So on to the notes. That was the warm-up. Now the notes. We'll actually be using x's in all of our numerators and denominators, but the concepts are the same. Common denominators for adding and subtracting, and make sure that you multiply by the reciprocal for dividing, canceling out common factors, simplifying your final answers, and we'll also do some things with complex fractions. But I want to start first by talking about what we mean by a rational expression. And so a rational expression is an algebraic expression that is a fraction, of course, with a polynomial in both the numerator and denominator. So if you look down here, in fact, this is a good example. You've got a fraction, and the numerator is a polynomial, and the denominator is a polynomial, and that makes it a rational function. So anytime you're talking about rational functions or rational expressions, you're talking about fractions that have x's in the top and or bottom. And in order to simplify a rational expression, or to remember that we've talked about this, sometimes it's hard to know when you're finished with a problem, or when you're finished simplifying something. And so here we'll say that a rational expression is completely simplified. If the numerator and denominator have no common factors. So if the numerator and denominator have no common factor. And I'm going to erase the little scribbly down here. So in this first section, example 1, I am going to just talk about simplifying these fractions. None of these is super straightforward, obvious, and so I just wanted to kind of walk you through some awkward looking or behaving examples so that you can see how exactly these would be simplified. And the first thing that you want to do, remember that the definition of simplifying is that the numerator and denominator have no common factors, and yet we don't know what the factors are in this numerator and denominator because they're addition and subtraction problems. They're not multiplication problems, and the only way to have a factor is to have a multiplication problem. And so you're hearing me say factor, factor, factor. So what you need to do then is actually factor. The word factor as a verb is the same as the noun factor when you're canceling factors for a reason. Factors are a thing a factor is a thing that's being multiplied, or part of an expression that's being multiplied. And so to get the factors, you have to factor a polynomial. And so we're going to factor the numerator and denominator. And so this is one of those places where I'm going to say to you, pause the video and scratch out real quick what the factors of the numerator and denominator are. And then come back and I will talk you through how this would look then when you're simplifying it. So when you look at the numerator here, the factored numerator, meaning the numerator is written as a product of factors. What I'm saying is that the biggest problem, you see a plus and a minus, but the biggest problem is a multiplication problem. And so that multiplication problem is the product of this thing called x minus 7 times this other thing called x plus 4. And so you can only cancel the whole entire thing that's in the parentheses with a whole other thing that's exactly like it that's also being multiplied in the denominator. So here I have an x minus 7, and here I have another x minus 7. Because each of those things is an entire unit that's being multiplied by something else, I can cancel those out because there's no greater or bigger addition or subtraction problem. The whole numerator is a multiplication problem. The whole denominator is a multiplication problem. And so my answer to this entire problem is x plus 4 over x minus 2. So this problem looks a little bit different, but remember that you can only cancel factors. And because the denominator has an addition in it, you want to see if it can be factored. And then after you've factored it, see if anything can be canceled. So there's a lot of ifs there. But when I look at the denominator here, x squared plus 5x, I see that there's a GCF. So the x is a GCF. And so I'm going to factor out the GCF. So now I have the denominator is x times x plus 5. Make sure that makes sense to you. And now my denominator is a multiplication problem. The biggest problem in my denominator is the thing called x times the other thing called x plus 5. And what you find is then that you have an x in the numerator that's not being multiplied by anything, but it's also not being added or subtracted from anything. So if it's the entire numerator or the entire denominator, you can cancel it. And I have an x as one of the things being multiplied in the denominator. Now be careful, because when you cancel that x in the numerator, you have you've left behind, or when you've actually divided out, and you've got a 1 in the numerator, and you have to write the 1. The 1 is not optional, and your answer is 1 over x plus 5. Now in C, I've changed it slightly. You still can't cancel or simplify this as is. You have to check and see if the bottom of the fraction, the only place where there's a plus or minus sign, you need to see if the bottom of the fraction can be factored. And in this case, it can't be factored. And you can't cancel the x and the x squared because of the plus sign. And because there's this plus sign here, because the biggest problem in the denominator is the plus sign, you can't cancel the x out of the x squared because it's part of an addition or subtraction problem. So I'm going to say that in this case, that rational expression is already completely simplified. So in letter D, you can think of the x plus 2 in the numerator as a thing, and it's exactly the same as one of the things being multiplied in the denominator. The denominator is made up of this thing called x minus 5 times this thing called x plus 2, and the x plus 2's cancel with each other. Again, in the numerator, that leaves behind a 1, And so your answer to this letter D is 1 over x minus 5. Now I want you to visually compare letter E to letter D. The only thing that's different is that I didn't put parentheses around the x minus 5. But that changes what the biggest problem is. What that does is it says that the biggest problem here in the denominator is a subtraction problem. This problem says this thing called x minus this whole thing called 5 times x plus 2. And since the biggest problem is a subtraction, you cannot cancel. And this whole entire denominator can't be factored at all. And so your answer here is, again, already completely simplified. Now in letter F, I want you to remember that subtraction can't just randomly be written forward and backwards. X minus 4 and 4 minus x are two different expressions, and therefore they wouldn't have the same answer. And so you can't just say, oh, those cancel each other out and it's 1, because it's not equal to 1. But what you can think of here, your thinking, is that this thing up here is the same as negative 1 times x minus 4. And just to kind of stress that, if you were to factor a negative 1 out of here, the 4 becomes negative and the minus x becomes positive. So I just took a GCF of negative 1 out of that and keep the same denominator, x minus 4. And now x minus 4 and x minus 4 cancel, and you're left with negative 1. So the answer to this is negative 1. But what I would say is look for this pattern where you have a factor in the numerator that is a subtraction problem and the same subtraction problem but backwards in the denominator. And when you factor or when you cancel those two factors from the numerator and denominator, instead of just canceling each other out, they'll leave behind a negative 1. And we'll look at that in a bigger problem in just a couple of minutes. Compare that to letter G, where we have the same addition problem, but the numerator has the addition of the denominator backwards, so 4 plus x and x plus 4. And because 4 plus x is the same as x plus 4 in the numerator, this whole entire fraction cancels, and your answer to this whole problem is positive 1. I want you to take a minute and just think about those two problems and make sure that you understand how they're different and why the answer is negative 1 for F and positive 1 for G. Before we go on to H and J, kind of eyeball them real quick. For F and G, these are the only two combinations of adding and subtracting 4's and x's that'll give you either a positive 1 or a negative 1. So for example, when I look at letter H, there's no way that you can rewrite -4 minus x so that it's going to cancel with x minus 4. If you tried to do the factoring out a -1 thing, -1 times that would be +4 and positive x, which is different than the denominator, which is minus. And so this is already completely simplified. That can't be simplified any farther. And similarly with letter J, again, you can't factor out a -1 and have the same expression. That would actually end up giving you -1 times x minus 4, which is not the same as x plus 4. And so that doesn't help you either. And so this is already completely simplified. So here I have just one example of each: multiplication, division, addition, and subtraction. I'm going to walk you through each one once. I'm going to start with multiplication because it's the easiest of the four, and they get more and more complex as you go from multiplication to division to addition to subtraction. And I think subtraction has extra steps or extra complications that none of the other ones have. So let's start with the multiplication. For all four of these operations with rational expressions, you absolutely have to start by factoring any factors or any of the expressions that are in a numerator or denominator. So for myself, I kind of go through each of these and I look at each numerator and denominator as separate objects first. So for example, I say here I have a numerator, a denominator, a numerator, a denominator. And I see that all but the second denominator can be factored. And I'm going to start with the numerator, the first numerator. There's a GCF of 4x that's in both of the terms. And so that's going to be 4x outside parentheses times x minus 1. And then in the first denominator, that polynomial, this is one of those places where you want to pause if you need to real quick factor that yourself. And you should get x plus 3 times x minus 1. And then in the second numerator, again, pause it real quick, factor that, and then come back, and you should get x plus 3 times x minus 2. And then, like we said, that last denominator cannot be factored. It's already a multiplication problem, 4 times x. So it's already factored into its most basic factors. And then I can go ahead and look at canceling anything that can be canceled. You can cancel, when you're multiplying, you can cancel from any numerator to any denominator as long as the whole problem is a multiplication problem. So here I have nothing but multiplication, and I have an x minus 1 here and here. I have an x plus 3 here and here, and I have a 4x and a 4x. And so the only thing that I have left in the denominators, it's all ones. and in the numerator is just that x minus 2. So my answer to this entire problem is x minus 2 over 1, but we don't really write over 1, so it's just x minus 2. Now for division, I don't care if you factor first or flip first or factor and flip all at the same time. But what you eventually want to do is look at this as I have a numerator that can't be factored further. I have a denominator that has a GCF. I have a numerator that also has a GCF. And I have a denominator that can be factored. And so in this first fraction, leave the 2x like it is. Then there's a GCF of 3 in the first denominator, so that's going to be 3 times x minus 4. And now remember that you're going to flip the second fraction. I'm going to change this to multiplication. And then I'm going to look at the yellow. Go ahead and factor that now real quick. And you should get x minus 2 and x minus 4. And I'm going to write it in the numerator because you're flipping or you're taking the reciprocal of the second fraction. And then in the numerator here, that's going to become my denominator. I see that I have a GCF of x. And so that's going to be x times x minus 2. Now I treat this just like a multiplication problem. I have an x here and an x here. I have an x minus 4 here and an x minus 4 here. And I've got an x minus 2 here and an x minus 2 here. And the only things left are the 2 and the 3. And so my answer to this whole problem is 2/3. So, for both addition and subtraction, notice that I start with you must have common denominators. And then you only add the numerators. So, the other thing that I want to remind you from the warm-up, and it's kind of, if you still have your warm-up close by, it's the problem that had the denominators that were 10 and 3. It was number 3 on the warm-up. If neither one of them is a factor of the other, or neither of them has a common factor, then you just multiply them by each other. So you're, and when you look at your answer keys, if you get answer keys from me, what I do is I write out the least common denominator as x minus 3 times x plus 2. And so my LCD, or least common denominator, is going to be the product of the two denominators that you have. But in order to get x minus 3 times x plus 2, I have to multiply by the x plus 2 in the numerator and the denominator. And in order to get x plus 2 times x minus 3 here, I have to multiply by x minus 3 in the numerator and the denominator. So now notice that both fractions now have this common denominator, x plus 2 times x minus 3, or x minus 3 times x plus 2, it's the same thing. And so I'm going to write the entire numerator here as one ginormous addition problem. So 3 parentheses x plus 2 plus 5 parentheses x minus 3 all over, and then my common denominator x minus 3 times x plus 2. To simplify this, I'm going to distribute the 3 and the 5 in the numerator. And so 3x plus 6 plus 5x minus 15. Keep the same least common denominator. You do not need to multiply or FOIL that. And then simplify your numerator, combining like terms. And so your answer would be 8x minus 9 all over x minus 3 times x plus 2. Now, I hope that you can see that the numerator, 8x minus 9 here, cannot be factored. But if it could be, the question always comes up, do I have to factor it? And it's a sometimes yes, sometimes no thing. You might need to factor it to see if anything would cancel. Because remember that if something can cancel, if you can simplify it, you have to simplify it. But if nothing's going to cancel, then you don't have to factor it, even if it can be factored. You'll get a feel for it. Now, the only difference with subtraction, remember I said that I think that it's a little bit more complex than the other ones, is that you always have to remember to distribute whatever is in the numerator here. And you don't see parentheses now, but when you get your common denominators, you're going to have parentheses in the numerator, and you're going to need to remember that that 3 is actually a negative 3 when you distribute it. So the other thing that I want to point out is that you always have to, or remind you of, is that you always have to factor something that can be factored. And in this case, x squared minus 4 can be factored to be x plus 2 times x minus 2. Now, if you want to make these two denominators the same, you've already got x plus 2 in both denominators. And so you don't need to multiply through by the x plus 2 again. All you need to do is multiply by x minus 2, but remember to do that in the numerator and denominator. And now both denominators are this x plus 2, x minus 2. And so that's going to be your LCD. I'll zoom back out in a minute, but your least common denominator is that x plus 2 times x minus 2 that we just made both of the denominators look like. And now I'm going to take this whole entire numerator subtraction problem thing, and I am going to write it as one big numerator, so 7 minus 3 parentheses x minus 2 all over, and then the LCD, or the least common denominator, x plus 2 times x minus 2. Here's a mistake that I see some students making. They see the x minus 2's and they want to cancel them. But in the numerator, your biggest problem is, hang on a second, your biggest problem is subtraction. And so you cannot cancel the x minus 2's because you're actually canceling it out of a subtraction problem. You can only cancel out of a multiplication problem. So in this case, you have to start by simplifying the numerator. So that means distribute the negative 3 So now I've got 7 minus 3x plus 6 over my least common denominator doesn't change, x plus 2x minus 2. Now I want you to stop for a second and just look close and make sure you understand why that's plus 6 and not minus 6. And then you have to combine the 7 and the 6, so now I have minus 3x plus 13 over x plus 2 times x minus 2. Negative 3x plus 13 doesn't factor, and nothing would cancel, so this is completely simplified. And there's your subtraction. So now we are going to take a look at simplifying a complex fraction. And a complex fraction is just a fraction that has fractions in the numerator and or denominator. And just remember that this is just one big division problem. And what you want to do is simplify the whole numerator, simplify the whole denominator, and then divide whatever answers you get. So for example, here, if I look at this, this monstrosity, I have this addition problem that is the numerator, and I have this subtraction problem that is the denominator, and I want to get answers to each of those. I want to simplify the numerator, I want to simplify the denominator, and get one fraction as an answer, and then do fraction division. So let's start just with the numerator. And when I look at this numerator, what I see is that I've got a fraction with an x minus 4 in the denominator, and I've got a whole number 2. Remember that if you have a whole number, you write that over 1. So I've got a second fraction that's being added that has a 1 as the denominator. And so what I want to do is have that denominator be the same as the other denominator. That'll be x minus 4. But if I multiply 1 times x minus 4, I also have to multiply the 2 times x minus 4. And sorry, I didn't turn the sound on my phone off, and it keeps beeping. Sorry. And I'm not going to re-record that. At least I waited until the clock had gone off before I came back to this page of the notes, because it was going off just as I was turning off the last page. So anyway, this entire numerator then becomes here, just the numerator part, so I'll do it in green. You end up with 6 plus 2 times x minus 4 all over x minus 4. And I forgot to move my papers around. Let me leave that there for a minute. You're going to eventually distribute the 2 and simplify the numerator a little, the numerator in the numerator a little bit further. But let's go ahead and also look at the denominator. So in the big denominator here, I have a fraction that has 4 over x minus 4, but it's a subtraction problem. And this 2 is also over 1, and so I need to multiply by x minus 4 here and times x minus 4 here. And so that whole denominator then becomes 2 times x minus 4 and then minus 4 over x minus 4. And that whole thing then is one massive fraction. This is the next step in what was being simplified. So what I am going to do next, just because it's easiest, is I'm going to take my two numerators and simplify them. I'm going to distribute the two in each case across the parentheses and then combine like terms. So over here in this fraction, my numerator in the green fraction on top is going to be 6 plus 2x minus 8 over x minus 4. And in the bottom, I end up with 2x minus 8 minus 4 over x minus 4. And kind of stop for a second, make sure that you track with all of my steps. And I really haven't dealt with the biggest problem here, which is the division problem, because I'll do the dividing at the very, very last step. And then here I'm going to simplify farther so that I end up with the 6 minus 8 is negative 2. So I end up with 2x minus 2 over x minus 4 in the numerator, and then minus 8 minus 4 is negative 12. So here I have 2x minus 12 over x minus 4. Now I'm going to say it one way, but I'm going to write it a different way. But remember that you can, if you see that you have a fraction over a fraction and the denominators are the same, you can just cancel the denominators. And you then just have 2x minus 2 over 2x minus 12. But, hang on, stuff is going to be moving around. I hope you see the pink. If you don't see the pink, sorry, I drew it, but sometimes this app does weird things with the video recording when I do an undo. So anyway, what I want to do next then is go back to what I had said about dividing, that it's like multiplying by the reciprocal. So now I've got 2x minus 2 over x minus 4 times x minus 4 over 2x minus 12. And because what had been originally the two denominators are exactly the same, you can just cancel them. And so this x minus 4 and this x minus 4 cancel. So now you have 2x minus 2 over 2x minus 12. Now, we're not done yet. Make sure you see how I got that far. But the last thing that you want to do is look at the numerator and denominator and ask yourself if there might be any common factors. If you were to factor the numerator and if you were to factor the denominator, is there anything that's in common to both of them? And I see that they both have a GCF of 2. So the numerator becomes 2 times x minus 1, and the denominator becomes 2 times x minus 6. And the 2's cancel. And so my final answer to the whole problem is x minus 1 over x minus 6. So the last part of what you're going to need to be able to do with rational expressions or rational equations is that if I give you a rational equation, you're going to need to be able to solve it. And so there are two different methods for solving these equations, and it's not like you want to pick your favorite and then use your favorite all the time. I mean, you could do that, but that's kind of tricky. What I would suggest is learning both methods and deciding when one is going to be more advantageous to use than the other. Now, I want to start by reminding you what the word solving means. when you solve something, remember that when I give you an equation, or when you're given an equation and you're asked to solve, first of all, it's always going to be an equation. So if you zoom back out up here, I gave you this complex fraction. I didn't ask you to solve it, I asked you to simplify it, because there was no equal sign there. And the word solve always has to do with an equation, and it always means figure out what x equals. Solve always means x equals and then what number. And it's always going to be a number. So that this question right here, you're going to do stuff, and then it's going to be x equals a number, and your answer, if the directions say solve, your answer is going to be x equals a number. No matter what you do in the middle, your answer will be a number. So now I'm going to go and I'm going to erase all my scribbles, I hope. So the first method here that I'm giving you is that you want the goal of having one fraction on either side of the equal sign. So here, for example, on the right hand side, you've got two fractions. So start by subtracting just those two. Ignore the 1 over 6x squared for a minute. Just look at this subtraction problem and say, okay, I need to multiply this by 3x, and then it'll be 3x squared. 3 times x, 3x squared. And so I have to multiply by 3x in the numerator. And so that entire fraction becomes numerator 1 minus 3x all over 3x squared. Now I have one fraction. Don't even check to see if it's simplified. If you want to, you can, but you don't have to. But I've got 1 minus 3x over 3x squared. Hint, it already is simplified, but it doesn't have to be. I'm going to bring down the other side because the other side was already a fraction. So now I have a fraction equals a fraction. And so the next thing that I'm going to do is look at the cross products. And so whenever you have a proportion, this is really a proportion, right? Proportion is numerator over denominator equals numerator over denominator. So a fraction equals a fraction. Anytime you have a proportion, if you multiply the numerator of the one times the denominator of the other, it should give you the exact same answer as if you multiply the denominator of the one times the numerator of the other. Those two cross products should be equal. And so here, I'm going to start with 1 times 3x squared, and that should be equal to 6x squared times 1 minus 3x. Now you have an equation that doesn't have any denominators, and you're just going to simplify each side and solve this the way you would solve any quadratic. So 1 times anything is itself, and distribute the 6x squared, and now you have 18x to the third. I am going to subtract 3x squared, from both sides so that this side is 0. And so now I have 0 equals 3x squared minus 18x to the third. The next thing that you want to do here is see if you have a GCF, which you do. Your GCF is 3x squared. And so that's going to be 1 minus 6x. Now, when you get to this part, remember, if you have a multiplication problem that's set equal to 0, you can take each of the things that are being multiplied and set each of those equal to 0. So I'm going to say, okay, 3x squared equals 0. and 1 minus 6x equals 0. In this first one, x is 0. In this second one, 1 equals 6x, or 1/6 equals x. So it would look like you have two answers, but wait for it. Up here, I have a note that you need to remember to check for extraneous solutions. So just a really quick reminder of what is an extraneous solution. You learned about that a little bit in Algebra 2. Extraneous solution means that you didn't make any mistakes in solving the problem. Both of those answers, 0 and 1/6, are algebraically justifiable, but one or both of them is not actually a solution of the graph or the function, because it would make one of the denominators equal to 0. In this case, and you would have to test both. So in this case, if you substituted 0 here or here or here, that would make all three of those denominators 0. And so you need to, and I actually would like you to write this, show that you got 0 as an answer, but then indicate that you know that it's an extraneous solution. But then here, and I'm going to go back and erase my scribbles. Here, I said I was going to erase my scribbles, and I'm erasing my scribbles. Okay, here, if you substitute 1/6 here, that's not going to give you 0. You don't actually have to walk it through. 1/6 squared is 1 over 36. That's not going to be 0. 1/6 here, that's still that 36, that's not going to be 0. And 1/6 here, that's not going to give you a denominator of 0. So 1/6 doesn't give you denominator of 0 anywhere, and so 1/6 is a solution to this problem that works. And so it's not extraneous. So your answer is just 1/6. If you were looking at this problem in a textbook, let's say, you know how some textbooks have the answers to odd questions in the back of the book? It would just give you the question and the answer and not give you all the work. And the textbook would say x equals 1/6. The textbook would not say you get 0 as an extraneous solution. What I'm going to do in a couple of minutes is actually take both this problem and the next problem, which also has an extraneous solution, and I'm going to add a segment to the video where I walk you through how you can look at that on Desmos. So that if you're not sure if you solved it correctly, you can both check your answer, x equals 1/6, and you can check to make sure that there are no other answers, and you can see why x equals 0 is extraneous. So the second method of solving rational equations is to find a common denominator that would work for all of the fractions on both sides of the equal sign. Change all three fractions, or all the fractions if there's however many fractions there are, to the same common denominator, and then only solve the numerators. So here's what I mean. First of all, you should notice that the last denominator, the x squared minus 9, can be factored. So x squared minus 9 is x plus 3 times x minus 3. And when I look at the other two denominators, I can multiply the first one by x plus 3. I can multiply the second one times x minus 3. So x plus 3, x minus 3 is my least common denominator. I'm going to write that off to the side. So x plus 3 times x minus 3 is my least common denominator. And I'm going to take that first fraction and I'm going to multiply the numerator and the denominator by x plus 3. I'm going to take the second fraction and multiply the numerator and the denominator by x minus 3. And now if you think about separating all three fractions here, this fraction has the least common denominator, this fraction has the least common denominator, and this fraction already had that least common denominator. So they all have x plus 3 times x minus 3 as the common denominator. And now you're just going to get rid of the denominators and you're going to solve the numerators. So I'm going to solve the equation x times x plus 3 plus 2x times x minus 3 equals 18. I'm going to take that equation and solve it as is. X times x plus 3 plus 2x times x minus 3 equals 18. Distribute your x and your 2x, so I get x squared plus 3x plus 2x squared minus 6x equals 18. And now I'm going to both simplify by combining like terms, and I'm also going to bring the 18 over to the left in order to have the whole equation set equal to 0. So when I do that, I end up here with 3x squared and then minus 3x and then minus 18 equals 0. Now here's the step where you can't miss the GCF, because if you miss the GCF, you're going to have a heck of a time factoring this, and you really, really want to factor this correctly. And so the first thing you're going to do is factor out the GCF, which is 3. That gives you x squared minus x minus 6, which is quite a bit easier to factor than 3's and 18's. So take a minute and factor that. Pause the video. I'm not going to do it for you. And when you're done, you should get 3 times x minus 3 times x plus 2 equals 0. Now, when you have a multiplication problem set equal to 0, remember that you take each part or each thing multiplied and set each equal to 0. But if it's a number that's being multiplied, like the 3 here, obviously 3 can't equal 0, so you don't bother with that. So your two answers for this equation are x equals positive 3 and x equals negative 2. But before you just put a box around them and move on to the next problem, what you want to do is check to see if either of these is an extraneous root. So you're going to go back up to the original equation up here, and you're going to say, look, if I substitute 3 into here, 3 minus 3 is 0. So 3 is extraneous. Doesn't matter what happens in any of these other equations or any of these other denominators. It would actually make this one 0 as well. Doesn't matter that it doesn't make this one 0. If it makes any of the denominators 0, any of them, then this here is an extraneous root, and you want to put a line through it and tell me that it's extraneous. And then do the same thing with the negative 2. Negative 2 minus 3 would be negative 5. Negative 2 plus 3 is positive 1. Negative 2 squared is 4. Minus 9 is negative 5. All three of those are non-zero. So negative 2 is a good solution. That's good, and that's the only solution to this problem. Now, hopefully what you'll see next is a video that I am going to make on Desmos where we look at using graphs to help solving equations. But I have to make the Desmos video separate from this video. That's why I'm hesitant and being non-committal about whether or not you'll see that video or not coming up next. I just have to remember to make it and then splice it in. So anyway, having said all of that, watch the Desmos part of the video, especially those of you going on to take calculus, using graphing software to check equations that you're solving really helps when you're getting into more and more complex equations. And even though you'll normally have to show your work algebraically, it kind of gives you a start at understanding how the graphs and the functions work and how they intersect with each other. So anyway, show you a Desmos video, and then after the Desmos video, the last 2 pages, or the last front and back of this notes packet, are problems for you to practice. So I'm not going to talk through all of them. I might pick and choose 1 or 2 to focus in on, but I will just give you the answers to those problems, and you can check them. I think I'm going to put that in the video as well as on Google Classroom. So here's Desmos. Talk you through looking at examples 4 and 5, the equation solving examples from the notes on solving and simplifying rational expressions and equations, and show you how you can use Desmos to check your solutions to equations and to take a look at why certain solutions are extraneous. And so what you want to do here, this first example for 1 over 6x squared equals 1 over 3x squared minus 1 over x. And I need to turn off the sound on all my devices. Forgot. Okay. So the first one, what you want to do is graph the left side of the equation and the right side of the equation as 2 separate graphs. So I'm going to type 1 over 6x squared in the first. Let me put this on projector mode so it's easier for you to see. And then in the second spot, I'm going to graph that whole subtraction problem, 1 over 3x squared, and then get outside. So I'm right arrowing to get outside of the denominator, and then outside of the fraction itself, and then minus 1 over x, and make sure that it looks exactly like it does on the paper. And so what we're saying is we want to find where this function or this expression is equal to this expression and what that x value is that would make them equal to each other. And the first thing that I want you to notice is that both, and did you know that you can toggle on and off graphs over here by clicking on the circle? Both the red, which is the left side of the equation, and the blue, which is the right side of the equation, they both have a vertical asymptote at y or x equals 0. And since x equals 0 is a vertical asymptote for both of them, x equals 0 cannot be a shared solution, because what you're doing is you're looking for an x value that's a solution to both sides of that equation. And therefore, that x equals 0 that you computed is an extraneous solution. But then we wanted to check the 1/6. And just in case you want to check the decimal value of 1/6, because Desmos is going to give you a decimal value, you can type 1 divided by 6. And over here, Desmos, remember that Desmos acts as a calculator, and if you do 1 divided by 6, the answer to that as a decimal is 0.16666. Repeating, they round the last digit to 7, but it's really 1.166 repeating forever. Now, did you also notice that when you graphed these, there was this random point sitting here? Of course, they give you the x-intercepts and if there are any y-intercepts. They also give you maxes and mins, or local maxes, local mins. And in this case, this point up here is where both the red and the blue graphs intersect. And it's hard to see because as they get closer to the asymptote up and through here, that it's hard to see that they intersect rather than actually just going on top of each other. And so what I want to do, because I think that this is 1/6, is just zoom in really, 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 really close. Zoom in, zoom in, zoom in, zoom in, zoom in, zoom in, zoom in. Ooh, I lost the point. I think I lost the point. Where's the point? There it is. And so if I zoom in, I want that in the middle of the screen, zoom in, oh, my computer stopped zooming in. You should be able to see that it's an intersection. Anyway, you can see that the graph, I guess you can't. I did for a moment. Anyway, and you can go back home by clicking over here. That point is where those two graphs intersect, and they don't intersect anywhere else. They come real close, but they don't actually intersect. So that is example 4. Let's do the same exact thing for example 5. I'm going to type the left side of the equation first. So x over x minus 3 plus 2x over x plus 3. So that's the left side of the equation. And then on the right side of the equation, I've got 18 over x squared minus 9. Now, again, this point here, that's a local maximum, and on the purple graph, that's a local maximum. We've got x-intercepts. And if there were a y-intercept, well, that's also that the local maximum is here, also a y-intercept. But there's this other random point here that seems like it's not a local min, a local max, an x value or a y value. And as we see, it is x equals -2, which is the solution that we thought that was a solution. And you can see here when you zoom in a little bit that the black and the purple curves cross over each other. The other thing that I wanted you to look at is if the value that we said was extraneous, x equals 3, is actually extraneous. And it looks to me like there's an asymptote. This is x equals 3. If you're ever not sure about an asymptote, what you can do is graph x or y. So x equals is a vertical asymptote and y equals is a horizontal asymptote. So if I did x equals 3 here, and I can even change it to be a dotted line if I like that for asymptotes. And then I can kind of zoom out and say, yeah, that pretty much looks like it's going to be an asymptote. If it's an asymptote, and in fact it's an asymptote for both graphs, although it doesn't have to be, if it's an asymptote for either graph, there's no way that the graphs can share an x value at that point. And so your solution for number 5 is just this x equals -2. So did that kind of make you feel like classes are changing? I know some of you hate that song, but it's just so happy. Anyway, better than elevator music? Well, here we go. Hopefully you have paused the video, that you've worked out the problems on the next couple of pages. And what I'm going to do here is just show you the answers. So I'm just going to zoom in on like 4 or 6 problems at a time, and then let the video just sit, and you can pause it and write what you need and check what you need to check. But I'm just going to go just forward through the answers, and I'm not going to talk about anything, more or less, I hope. We'll see if I can restrain myself. So here goes. And I had to scan these in my phone because I couldn't get into the school to scan everything. Sorry that it's a bad scan. Two of the problems I've worked out on a separate sheet, so I will show you those at the end. Let's start just with these first few.